Today I'm going to present about the computer vision mini project, which is font detection. Here is our group members. For the project concept, we want to create a program that detects the text and recognize what the font name of it. And this project is also work along with the AI security class, so we will use the AI algorithm to predict the font name. And for the CV class, we will use the concept of image augmentation to create the dataset for the AI model. And for the techniques, in the preparing process, we will use font forge to get the character from the font files, and also use a shear, rotate, and blur technique for create the dataset. And for the prediction process, we will use the threshold to remove a background, and also use the morphological reconstruction. And we will use crop and resize image for the preferred area and the character for prediction. First, let's talk about dataset preparation process. For the font image extraction, we will use font forge to extract the alphabet image from the font TFF files, and which we have the total of 14 font families. This font is normally used in the report, and some other we can find on the internet. And here is the font image extraction. For the preparing process, after we use font forge to extract the image for each alphabet from its fonts, we will use the augmentation techniques to augment the image to create the dataset for the training the model. Since the image we need to prediction might have the resolution, out of focus, or taking from the different angles. So we will use the rotation, shear, and blur function from the OpenCV to make the dataset. And here is the code for the image augmentation. And here is the flowchart from the image augmentation.
For the training data, I use fontform.exe with this script to generate from the TTF file, that is the font file, to be the image file for every font and every character. And from this image, I will do the augmentation using computer vision technique to generate more training data. For the augmentation technique that we use is blurring, rotating, and shearing. For blurring function, we can set a stop, and this function will loop from the kernel size is 1 and step by 2 until the stop. The kernel size is 1 is no blurring, and step by 2 because it will increase the blurring level, and step by 2 for the kernel size will be the odd number. The rotation, you can set the start degree, stop degree, and step degree, and the function will loop. The same as the shearing function that have start degree, stop degree, and step, and it will loop. Then we need the config function because pick image from the fontform.exe is not crop fit to the character, so we need to crop fit it, and the result will be something like this. It will crop, but it's not square, so we need the crop to square function, this function, to place the crop fit image into the middle of the square background. This function I will set the background larger than the crop fit image 120%. First, I loop to, this is the loop code, and after loop you can read all of image and crop it to square. Right. Then we will blur. After blur, you will have a list that have blur level from 1, 3, 5, 7 until 13, and it will loop the blur list to rotate and shear. So the output will be rotate and will be blur and rotate and blur and shear. Blur and rotate, and we will increase the rotate level and increase the blur level, shear level, something like that. This is all of our augmentation.
Next, let's talk about font prediction process. For the preparing image for detection, we need to extract the text from the input image. We might have not planned backgrounds, so we use threshold and control techniques to find the area of the alphabets, and also resize to have the same as the dataset to predict the font name. And here is the flowchart.
For the prediction part, since our AI model is quite slow to predict, so I decided not to create a real-time prediction and create a UI program instead that you can browse the image. But this is the perspective image that have low confidence score. So we create a function that can detect the mouse location and get the position that you click. So you can do the perspective transformation and make it right again. And your confidence score is increased. For some angle, it is better. Now let's see how I can predict this image. First, I have predefined the class image prediction that I write at the beginning of the program. So when it starts program, it will define. And then when you browse image, the image will be read and that image will be put in the getImageCorner function that I have shown you before, that you can click 4 points in the image and it will do the perspective transformation and you will get this image. Then you can send this image to predict. In predict is the function in the prediction class, this class, prediction. For the predict, we have the pre-processing path and predict path. The predict path is about AI. So for computer vision, I will introduce two functions, that is get region of interest and pre-processing. For get region of interest, first we will convert image to grayscale, and that grayscale we can convert to black and white image by using binary invert method. Then I will do the contour to find the bounding box. After contour, we loop for each contour and get the bounding box and crop it to region of interest. So you will get each character. But there is some problems for the character that is formed to the word. For example, this font. If I want to predict SIIE, I have to bounding box SIIE and get only SIIE to put in the model and predict. But now, if I bounding box SIIE, I will get some part of Rodua that is bad for prediction. The concept to get rid of Rodua is you can find the map area of contour area in this small area. And if the area is not the max area, you just place it with 0, that is black. So let's see the code. Now I I have region of interest that has border now, and I just find the contour area in this small area and find the max contour area. Then if it isn't the max contour area, just place that area to width 0, so it will get black. Let's see if the code works. This is O that I have put the border area with black. So now we have get region of interest. Now we just do the pre-processing. The pre-processing is like the training data because it has just crop to square and reshape to 100 to 100 because the image is not this size, but the model requires this size.
And for the results, we will use the PyQt file library to create simple UI to upload the image and show us the result for the AI predictions. And here is the program flowchart. For the further applications, since we have only 14 fonts for this model, so in the future, we can apply this concept for the other fonts. Like we can create a web application to allow the people to upload their own fonts to this model. And since this project has the small size, so it can be ported into the mobile device in the future. Thank you for your listening.